Hello everyone. In today's session we are solving the fourth problem in module 1, that is converting the one line diagram into a reactance diagram. So this is the given problem. The one line diagram of an unrooted generator is as shown in the figure. For this you have to draw the per unit impedance of the reactance diagram. So here you have to choose a base of 50 MVA 13.8 kilovolt in the circuit of generator 1. So please do underline this. 13.8 in the circuit of generator. That means the generator value 15 MVA, 50 MVA, 13.8 will be the reference or the base value. So next they have given the ratings of the generator and transformer as follows. The generator 1 will be 20 MVA, 13.8 kilovolts. So we will write accordingly 20 MVA, 13.8 kilovolt, and the reactance X is equal to 0.2 per unit. This is the ratings for generator 1. Similarly, for the generator 2, it is 30 MVA, 18 kilovolt, then X is equal to 0.2 per unit. Then for generator 3, it is 30 MVA, 20 kilovolt, X is equal to 0.2 per unit. Next, the transformer T1. So this is a transformer T1. This is having the rating as 25 MVA. So this is, that step up transformer, the primary winding will be having a low voltage, secondary will be having a higher voltage. So 13.8 kilovolt slash 220 kilovolt. Then X is equal to, it is given in percentage, convert this into per unit, that is 0.1 per unit it is. This is dividing 10 by 100 will get 0.1 per unit. Similarly, the transformer T2, see this is quite different when compared to the previous problem. What they have given for the transformer T2, it is not a one single three phase transformer, it is a 3 single phase unit. So this is composed of a 3 single phase transformer, and each single transformer it is rated for 10 MVA 127 kilovolt slash 18 kilovolt, and the reactance will be 10%. So what that means, what we have to do means, before writing this rating in the transformer 2 data, first we have to convert this 3 single phase unit into a 3 phase transformer. Okay, so this we'll do it later. Before that we'll write the data of transformer T3. So the transformer T3 is having the MVA rating as 35 MVA, and the reactance is 10%, converting into per unit is 0.1 per unit, and the voltage rating. So this is a step down transformer because this is connected to generator. So now what we have to do? So the primary side will be having a lower voltage here. So 22 kilovolt slash secondary side will be having higher voltage. So always the higher voltage will be connected to the transmission lines. So here 220 is connected to transmission line, here 220 is connected to transmission line. Similarly for this also higher voltage will be connected. So the next is, before going for the procedure, we need to convert the 3 single phase unit into a 3 phase transformer. So since the transformer T2, the primary side is star connected and the secondary side is a delta, and even you can observe the primary side will be having a higher voltage of 127 kilovolt. So in such a cases, for converting a 3 single phase unit into a 3 phase transformer, so how we have to convert means, the winding which is having a higher voltage and that is a star connected means, for that winding you need to multiply it with root 3 factor. So here observe, the primary side is star connected and it is having a higher voltage rating of 127. So for the higher voltage rating and it is star connected, I have multiplied with the root 3. So after multiplying 127 with the root 3, you will get 299.9. So considering a whole number, 220 kilovolt I have written. Similarly, the secondary side I have kept as it is. So now the new rating of the transformer T2 will be 220 kilovolt by 18 kilovolt. Similarly, the power rating, that is MVA rating given for 3 single phases 10 MVA. So this also we supposed to convert it into a 3 phase transformer. So that is why multiply 10 into 3. 10 MVA for each of the rating of the transformer for converting into a 3 phase. So we'll get 30 MVA. So this is the new rating of a 3-phase transformer. So this rating will write here. So the rating on the primary side is 220 kilovolt slash the secondary side will be the lower voltage 18 kilovolt, and the new MVA rating, it is not a 10 MVA, converting that for a 3-phase transformer it is 30 MVA, and the reactance will be as it is, X is equal to 0.1 per unit. So the most important thing you have to remember is, when the 3 single phase transformer is given means converting that into a 3-phase means, so for the higher voltage rating of the transformer, and that is a star connected means, for that side you have to multiply it with root 3. So then we can convert a 3 single phase into a 3-phase transformer. So now we can go with the procedure. Step 1, choosing a base power for the entire system. So now look at the given data. In the problem they have given 50 MVA. So this will be the base power. So this we will write it as MVA base new. So the step 1 is choosing a base power for the entire system. MVA base new will be equal to 50 MVA. So that completes step 1. Proceeding with the step 2, that is calculation of a base voltage for generator, motor and transmission line. So since in the given single line diagram there is no motor is mentioned, so only the generator value is there, generator and transmission lines are there. So what we can do, first we will consider the reference value. So in your given single line diagram they have given generator 1 the base voltage to be considered as a reference value. So now 13.8 kilovolt will be the kilovolt base new of the generator 1. So in the step 2, kilovolt base new of the generator 1, that is equal to 13.8 kilovolt. So this will be your reference value. By taking this as a reference, next we will calculate the base voltage of the transmission line. We have 3 transmission lines are there. All the 3 transmission lines are connected to one common bus bar. Then we need to connect the base voltage for the generator G2 and also for generator G3. Since these two are coming on the LT section and this transmission line is coming on the high tension section. So first we will calculate for the transmission line. So kilovolt base new for the transmission line, that is equal to, first we will write the HT section formula, that is kilovolt base new of on HT section multiplied by high voltage or LT section, this is LT section, HT rating divided by LT rating. One important thing you have to observe while doing the calculation for the transmission line, see this is the same transmission line with the different reactances, but it is all carrying the same voltages. Observe, this J80 ohm transmission line is connected to 220 kilovolt secondary side of the transformer, and this is also carrying a 220 kilovolt, and this J50 ohm transmission line also it is carrying the same voltage. Since all the transmission lines are carrying the same voltages and it has been connected to a same bus bar, so we can go with the one single base voltage calculation for the transmission line. So instead of doing 2 times or 3 times of the base voltage calculation, all the 3 transmission lines are carrying the same voltage, so we'll go with the one single calculation only. So this value will be same for all the transmission lines, that is J80 ohm, 100 ohm and also for the J50 ohm line it is. Now kilovolt base on LT section. LT section is nothing but the low tension section, that is already given in the problem itself. Generator value 13.8 kilovolt multiplied by HT by LT rating. So now again look at the given single line diagram. So you are calculating the transmission line value by taking generator value as a reference. So in between this transmission line and a generator, we have a T1 transformer is coming. So the high voltage rating is 220 kilovolt, low voltage rating will be 13.8. So same way we'll write here. This is high voltages or high tension is 220 divided by 13.8. So now cancelling this, we'll write the reactance, the base voltage as 220 kilovolt. So this will remains the same for J80 ohm transmission line, J 100 ohm transmission line, then J 50 ohm. So for all the three reactances of the transmission line, we have a same base voltage of 220 kilovolt. So next, similarly, we'll do the base voltage calculation for the generator 2. So for this you have to write the LT section formula. So this is the LT section formula. So here kilovolt base nu on HT. HT is always the transmission line. So that base voltage just now we have calculated, it is 220 kilovolt multiplied by the transformer rating. So now look at the single line diagram. We are calculating generator 2 value by taking transmission line as a reference. In between generator 2 and the transmission line, T2 transformer is coming. So we need to write high and low voltage rating. So low voltage is 18, high voltage is 220. So 18 by 220 kilovolt. So that will get 18 kilovolt. This is the kilovolt base nu for generator 2. Similarly, we'll do it for the generator 3. So again use the same formula for the generator 3 calculation. So now observe here, we are calculating the reactance of, we are calculating base voltage for the generator 3 and taking the transmission line as a reference. So between the generator 3 and the transmission line, we have T3 is there. So that high and low voltage will write. So before that, kilovolt base on HT. HT is nothing but again a transmission line. So that base voltage will be 220 kilovolt because this has been connected to J50 ohm transmission line. So that new base voltage is also will be equal to 220 kilovolt it is. So now LT rating by HT rating. So LT will be 22 kilovolt, HT will be 220 kilovolt it is. So here we'll write 22 divided by 220 kilovolt. So we'll get 22 kilovolt. So this completes step 2. Step 3 is reactance of transmission line calculation. See, now look at the given single line diagram. We have 3 transmission lines with the 3 different reactances are there. All are given in ohms. So what we have to do, we need to convert the ohmic value of the reactances into per unit. So we have the formula for converting ohms into per unit. First we'll do it for the J80 ohm transmission line. So X per unit nu for J80 ohm transmission line, that is equal to, write the formula, that is X in ohm multiplied by MVA base nu divided by kilovolt base square nu of the transmission line. So since we are calculating for the J80 ohm, so that reactance is J80 only multiplied by MVA base nu. So now look at the given data. MVA base nu given in step 1 is 50 ohm and kilovolt base square nu for the transmission line, that is 220 kilovolt whole square. So after this we'll get the answer as J 0.082 per unit. So next similarly we'll do it for the J 150 ohm transmission line. So in the same way I have done the calculation for 150 ohm using this formula. Only the X in ohm value will be changes and the MVA base nu and kilovolt base nu for the transmission line will remains the same. So now for J100 ohm we'll get the answer as J 0.103. Similarly for the J50 ohm transmission line we'll get the answer as J 0.0516 per unit. So this completes step 3. So next we'll proceed with the step 4, that is per unit reactance calculation for the generator and all the transformers. So this is the formula for per unit reactance calculation for the generator 1. So now look at the given data, X per unit volt given in a single line diagram. That is for the generator 1, X per unit volt will be 0.2 per unit and 13.8 will be the kilovolt base square old value and this will be the MVA base old values. So first we'll write all the old values. 0.2 the old value divided by MVA base old value will be 20 multiplied by the kilovolt base square old given in the problem is 13.8 kilovolt it is. So next we'll write the new values by seeing step 1 and step 2. MVA base new. So given in step 1 is 50 MVA. Then kilovolt base square new for the generator. So generator 1 is 13.8 kilovolt. So now we'll substitute the answer. We'll get the answer for generator 1 as J 0.5 per unit. So similarly we'll do it for generator 2 and 3. Now for generator 2, X per unit old value. Old value means the given value, it is 0.2 per unit multiplied by MVA base new, that is step 1 value 50 MVA divided by MVA base old. Old means given value 30 MVA for generator 2 multiplied by kilovolt base square old. Old is nothing but given data, it is 18 kilovolt divided by kilovolt base square new. New means step 2 value, that is kilovolt base new for the generator 2 is, again it is 18 only. So after dividing this, we'll get the answer for generator 2 as J 0.33 per unit. So next we'll do it for the per unit reactance calculation for generator 3. Use the same formula. So X per unit old for generator 3 is, again it is 0.2 per unit, 0.2 multiplied by MVA base new, that is step 1 value 50 MVA divided by MVA base old. Old is nothing but the given value in the problem, it is 30 MVA multiplied by kilovolt base square old. Old is nothing but given value, it is 20 divided by kilovolt base square new for generator 3. It is kilovolt base new for generator 3 is 22 kilovolt. So now substitute the answer. We'll get final value as J 0.275 per unit. So this completes the reactance calculation for the generator. So next we need to do the reactance calculation for the 3 transformers. This is the formula, the same formula only I have written for the per unit reactance calculation for the transformer. So here we need to do 3 reactance calculation for the transformer, because all the 3 transformer T1, T2 and T3, it is having different ratings. It is not having the same rating. So 3 reactance calculation we are supposed to make. So now seeing the first transformer data, the per unit reactance volt value given for the transformer T1 is 0.1 multiplied by MVA base new, that is a step 1 value, again it is 50 divided by MVA base old for the transformer T1 is 25 MVA multiplied by the base voltage. Since you know that the transformer will be having a two voltages, one is primary side and the secondary side. So you need to cross check for the primary as well as secondary. Make sure you are getting the same answer on either side of also. So that will do it here. Kilovolt base square old. So first we'll do it for the primary side. The primary volt value is 13.8 and this is been connected to generator. So the generator new value in calculated in step 2 is again that is 13.8 only. So 13.8 divided by 13.8 is, we'll get the answer as 1. Similarly cross check for the secondary side. Secondary side the old value given is 220 kilovolt and this secondary side is connected to transmission line. So the new value of the transmission line is, that is also 220 kilovolt it is. So we'll write 220 by 220. So answer is again 1. So our calculation is correct, the step 1 and step 2 calculation. So here I can side either side also, both the answers are same. So I have taken secondary side. So now we'll get the answer for T1 transformer as J 0.2 per unit. So next similarly do it for transformer T2. X per unit new for transformer T2 is equal to X per unit volt. So look at the volt value given for the transformer T2. It is again 0.1 multiplied by MVA base new will be 50. Step 1 value. MVA base old. Old is nothing but given data for the transmode 2, it is 30 MVA, multiplied by, again do the cross checking for the primary as well as secondary for the kilovolt base old and new value. So now consider I am doing it for the primary side, it is the 220, this will be the old value, and this primary is connected to transmission line. The transmission line new value will be, again it is 220, will get the answer as 1. Now cross check for the secondary side, the old value given is 18 kilovolt and this has been connected to generator G2. Now look at generator G2 base voltage. Generator G2 base voltage, kilovolt base new will be 18. So on this side also we'll get the answer as 1. So here also we are getting a same answer on the primary side as well as on the secondary side. So now I'll consider the secondary side value 18 by 18 whole square. So we'll get the answer for transmode T2 as J0.166 per unit. So next similarly do it for the last transformer T3, X per unit new for transformer T3 will be equal to X per unit old. Look at the old value, that is X 0.2 for the transmode T3 it is X 0.1. 0.1 multiplied by MVA base new will be same as it is 50 divided by MVA base old. Old value for the T3 transformer is 35 MVA. Multiplied by, again cross check for primary as well as the secondary side. So now I'll consider the primary side. Primary side is 22 kilovolt, 22, and this will be the old value connected to generator G3. So what is the new value of the generator G3? That is also 22 kilovolt. So 22 by 22 will get the same answer as 1. So now cross check for the secondary side. Secondary is a 220 kilovolt and this has been connected to transmission line. That new value, as you already know, it is 220 only, will get the answer as 1. So if you take the winding on the primary or on the secondary side means you will get same answer even on the T3 transformer also. So here I will write the first winding 22 by 22 whole square. So you will get the answer as J 0.142 per unit. So this completes step 4 calculation. So now we'll proceed with the last step, that is drawing the per unit reactance diagram. So this is a given single line diagram, converting that into a per unit value. So first we'll write the reactance diagram for generator 1. So this is the reactance for generator 1, source voltage for generator 1, and after that we'll write for the generator 2. This is the reactance for generator 2, source voltage for generator 2. So next we'll write in between component. After the generator we have transmode T1 is there, that is having only one reactance X T1. Next connected to a transmission line, consider X TL1, and for generator G2 we have transmode T2 is there, so that is having only one reactance X T2, and this T2 transformer is connected to a transmission line that is having one reactance X TL2, and in between that we have a one more branch is going, the same common bus bar is connected to one more network, that is a transmission line 3, transmode T3 and generator G3. So that will show in between. So first comes is the transmission line TL3. Next we have a transformer T3 is there, so that is having a one reactance. After that we have a generator is there, so that is having a reactance and a source voltage. So this is XG3 and this is the source voltage EG3. So now this completes the given reactance diagram. So before that you need to mention all the reactances values since we solved in step 3 and step 4. Now I have written all the reactances. So this completes the given problem. Thank you.